Next on the agenda is going to be Catherine Berg from the NOAA Office of Response and Restoration. Catherine is coming to us from Anchorage, so we're going to see if we can't do another remote setup.
All right, thank you. So, hello everyone. I'm sorry I couldn't be there. I really do enjoy coming to Dutch Harbor when I can get in, but apparently that wasn't going to be the case this week. So, trying to keep it quick here for Doug. If we'll just move to the next slide. So NOAA has primarily two roles during spill response. One you're very familiar with, the Natural Resource Trustee is the National Marine Fisheries Service, and they handle issues with regard to fish and marine mammals. I am more on the science and technical support role, and these are some of the things I'm just going to talk to you about today. So next. So NOAA, the science support role is within Office of Response and Restoration, the Emergency Response Division. It's an all hazards response support, chemical and oil spills. We provide support for more than 100 responses each year around the nation. We are an in-house team of scientists with and on call 24/7. When you can't reach one of us, you can call our emergency number, which we usually provide when we're not available. So there are 11 of us around the nation. I have Alaska, and you can see where some of the other folks are stationed, and our science support team is located in Seattle. So this is a list of our responsibilities during a response incident, and these you can find in the Incident Management Handbook. Generally, we do trajectory forecasting when there's an oil spill on the water. We can provide hazard information on whatever the product is. We try to seek consensus on any science issues that come up during response. We facilitate the Endangered Species Act consultation, try to help develop a prioritized list of resources at risk, so to help strategize the response. We evaluate different countermeasures, cleanup methods, and various endpoints, integrate the knowledge from the hazard and its effects to sort of advance our program for the next incident. And then we try to help facilitate the damage assessment program that will be going on at the same time. So our science support team, they're the ones that make us look good during a response. We have a number of oceanographers, modelers, biologists, and most of these folks are in-house in NOAA. Like I said, they're located in Seattle, but we also have a number of contractors that work with us and provide support. Gen West provides our data management out of Seattle. RPI provides our biological support out of South Carolina, and LSU Chemistry Lab helps us with sample analysis. So the Science Support Coordinator is located on the command staff within the Incident Command structure. However, we work very closely with the environmental unit because this is where most of the technical specialists reside. We work with the resource at risk folks, usually Fish and Game, Fish and Wildlife Service, National Marine Fisheries Service experts, historical and cultural resources. The technical specialist is located in the environmental unit. But we also work with the folks in operations for cleanup and for doing our SCAT, and I'll talk a little bit about that later. Basically, our science recommendations revolve around answering 5 questions during a response. What happened? Where will the product go? What could be the effects? What harm could it cause? And what can be done to help? And we'll run through these and talk about the various tools that we use. So the first thing we want to look at when we're called to an incident is what was spilled. We want to characterize the hazard. We have a couple of products that do that in 2 product libraries, basically. One is a chemical library under our Cameo suite of tools, and this is a program that allows us to search for different chemicals in the chemical database, print customized reports with response recommendations, find out how the chemicals would react if they were mixed, and various properties for the different chemicals that we're looking at. And then the ADIOS 2 library is basically a database of different crude oils. It has over 1,000 different crude oils and various refined products in the database. And it basically gives us estimates of the physical properties of the oils and the different products that could potentially be spilled. We also provide sampling and chemistry support, collecting oil samples, whether it's from the vessel that's at risk or from the environment once it gets spilled. And we help look at toxicity and then do fingerprinting for the Coast Guard on that. So the next thing we want to look at is where that spill would go. What would be the fate and transport of that oil once it's on the water. So next, we assist in conducting overflight observations. We're all trained to fly in helicopters and observe oil on the water. We basically will, when we go out over an oil spill, we'll map our flight line, collect notes, photographs, observations of what we see, and bring that back to the command and help them direct the response. And I'll talk about how this is used a little bit later in IRMA in the command center. We have a number of oil trajectory modeling tools. One is ADIOS. I already talked a little bit about that. But it's NOAA's oil weathering model, and it's an oil spill response tool that models how different types of oil weather, the different physical and chemical changes that occur once they're in the marine environment. And then we can marry that with our NOAA model. NOAA stands for General NOAA Operation Modeling Environment. And basically, it helps predict the possible route or trajectory of an oil and where it might go on a body of water after it's been spilled. It uses winds and currents and other processes that move it around and spread it on the water. And also NOAA itself learns how these predictions, learns from these predictions and sort of corrects itself as it goes. And then we also have a product called CHIO that just gives us information on tides, highs and lows, and the different tide currents. We also can do some hazmat air plume modeling. Cameo Chemicals, again, has an extensive chemical database with critical response information for thousands of chemicals. Aloha model can help predict the area that could be affected by a toxic cloud or of a release, and as well as any potential threats from chemical fires or explosions. It provides a graphical output which can include the threat zone and then the different threats at specific locations. And then we can take that Aloha plume model and incorporate it into what we call MARPLOT, which is a GIS interface, and you can overlay it on maps and look for your threat zones and potential evacuation zones from a chemical release. So the next question, what will be affected? We want to look at resources at risk. The first thing we look at is the shoreline. We have an ESI classification, Environmental Sensitivity Index shoreline classification that basically ranks a shoreline sensitivity to oil. And if you look at that graphic on the left, it shows cool colors moving to warm colors. Cool colars are shorelines that are less sensitive, and the warm colors are shorelines that are more sensitive to oiling, such as marshes and sheltered tidal areas. We also have within the shoreline type database descriptions of all the shorelines as well as predicted oil behavior if oil is spilled on that shoreline, and then some response considerations that we use to guide us in cleanup and remediation. And we also have the ability to use shore zone, and this is basically photos and video images of the shoreline throughout most of Alaska, and also has shoreline typing and information on the different biobands of shoreline. So if we can't get to a remote location, we can pull up shore zone for the most part and what we call virtually fly the shoreline and and see what the potential impacts or potential types of shoreline that could be impacted by a spill might be. We also look at the different biological resources that could be affected, birds, fish, mammals, invertebrates, and their different spawning, nesting, migration, whatever could be occurring at that particular point in time. And this is basically, our ESI maps are basically a snapshot. It gives us information on what could potentially be there at any time, but what we really want to do is work with the various area experts and folks that are local and may have more knowledge of what's actually happening at the time if we can't get there. And then the last resource at risk that we look at, of course, is human use, including different management areas, wildlife refuges, Forest Service lands, state game refuges, the different cultural and historic properties that could potentially be impacted, any kind of aquaculture or fishing that could be going on in the area, and then facilities that may be available to actually assist the response. So the next question is what kind of harm can be caused by the spill? We're basically going to evaluate the different impacts. And one of the things we use there is what we call a shoreline cleanup assessment techniques. And we have folks that are trained in this. We just did a training here in Anchorage back in June for the various agency folks that could potentially participate. So basically what we'll do is segment the shoreline. This is Scan Bay. Some of you may be familiar with this from the Selendang IU oil spill back in December of 2004. So this is what we first segmented the shorelines, and then we would go out and survey each segment and provide information on the level of oiling on that segment, and then recommend cleanup options. And you can see basically the levels go from heavy, moderate, light to no oil observed there on that map on the right. We also have a database called CAFE, which looks at aquatic fate and effects from the toxicity of whatever was spilled in the environment. We have toxicity databases for a number of chemicals, oils, dispersants, as well as we can also do a dispersant oil mix. And so basically, you answer a series of questions, and it spits out an exposure report, which is what you're seeing on the lower right there. And it allows us to view the risks and get like an estimate of what could potentially be at risk from any kind of a spill, from very high toxicity down to practically non-toxic. And it looks at different aquatic species at various levels and various levels of aquatic biota, and such as embryo, larval, juvenile, adult, and different stages of life as well. So what can be done? Well, we want to look at the potential environmental trade-offs of the various response options that could be used next. So anything from just booming to skimming, in situ burning, passive recovery, use of dispersants. We want to review all these different response options and try to balance what we call environmental trade-offs and try to pick the best response for any kind of a release. We also look at cleanup recommendations and provide recommendations to the federal on-scene coordinator. But beyond making recommendations, we also want to go out and have a little bit of oversight of how that's going. We want to work with the various task forces that are out there implementing the recommendations that we've made, and make sure that one, they're doing it in a way that we thought they might do it. And two, if it's not working how we thought it should be working, we want to modify and help make the best cleanup out there. So we talked about the spill location, the hazard characterization, fate, transport, resources at risk, survey data that we've collected, the response options we put in the field, and as you can probably imagine, it creates a large amount of data. We've also created, NOAA has created an environmental response management application, or IRMA. This is a web-based GIS tool that allows us to provide information to all the responders and the managers in a way that everybody's getting the same picture. So it takes base maps that are already created, and it incorporates things that are happening in real time and provides a good visual on the situation. And it really does help the communication and coordination of this bill by providing what we call a COP, or a Common Operational Picture. So this is something that we can display digitally in a command center, and as things are happening, different GIS layers can be created that show what's happening on site at the time, and allow everybody to have a common understanding of what's going on in the field. Basically, this is showing you what IRMA looks like. This is just one layer that was created. This is the Gulf of Mexico. It's called the Texas City Y incident, and it was where a barge collided with another ship and released a bunch of heavy fuel into the environment. So basically what we're looking at here is a NOAA overflight that had occurred in the morning, and you can see the little arrows show the flight path of that overflight, and then there are dots along that path where several observations were made, such as scattered patches or windrows of oil, shows the outer edge of the slick, or different kinds of sheen that we're seeing. And then those red flags are where photos were taken, and you can actually click on those photos and see what the observers in the aircraft were seeing during the overflight. And there's one picture that's highlighted there, and it just shows a heavy slick with silver sheen coming off of it. And so for those people in the command center that can't get out and see this, this information is collected and then brought into the command center. A layer is created and then put on IRMA and projected on the screen so that other folks can see what was seen during that field site visit. These are just showing some of the tools, job aids, manuals, fact sheets that NOAA keeps, and these are all available online. You can see that we have the FOSC's Guide to Science Support, how we would manage oil spills in marshes, dispersant application observer job aid. So these job aids are what we use, and they are available online. You can download them, or you can purchase them in the laminated bound format for, I think it's like $22 a copy. But basically, that's just the printing cost for those things. And that's all I have. Go next. So my information is down in the lower right-hand corner there. Those are my phone numbers. You can reach me by email. And then that website in the lower left-hand corner is where you can go look at our models. You can download the models and play with them, or you can play with them online. And then you also have access to all of our job aids at that location as well.